We need to give a clear meaning to our usual anatomic terms, medial and lateral, anterior and posterior. When we use those terms in the upper extremity, we imagine the extremity to be fixed in this so-called anatomic position. That's useful, but calling something medial or lateral can become pretty confusing below the elbow because everything can rotate so much. To get our bearings in the forearm and hand, we'll often use the more convenient terms that are derived from the two functions, flexion and extension, and from the two bones of the forearm, the ulnar and the radius. This is the flexor aspect of the forearm, and this is the extensor aspect. This is the ulnar side, and this side with the thumb on it is the radial side. Let's also understand the terms we use for movements. At the elbow, bending is flexion, straightening is extension. Rotation of the forearm is referred to as pronation and supination. Pronation puts the palm of the hand down, supination brings it up. To remember which is which, remember supination has up in it. At the wrist, this is flexion, this is extension. The two sideways movements of the wrist are ulnar abduction and radial abduction. There's one last term to define, the arm. In everyday conversation, this whole thing is the arm. But in anatomy, this is the arm, just this bit here. And this is the forearm. Now let's look at the bones, starting with the humerus. We've looked at its proximal end already. Now let's see the distal end. It's flattened from front to back, with a complicated articular surface and two prominent lumps, the medial epicondyle and the lateral epicondyle. These are major muscle origins, as we'll see. Above each epicondyle is a ridge, the epicondylar ridge. Here's the lateral one. The articular surface is in two parts. The pulley-like trochlea articulates with the ulna. The rounded capitulum articulates with the radius. Now we'll add the radius and the ulna to the picture. The big hollow on the back of the humerus, the olecranon fossa, accommodates the end of the ulna, the olecranon, in full extension. Now let's look at the two forearm bones, the radius and the ulna. They're different in that the ulna is bigger proximally, the radius is bigger distally. They're also different in that the radius rotates, the ulna doesn't. The two bones are held together by two radio-ulnar joints, the proximal and the distal. Forearm rotation happens simultaneously at both these joints. The two bones are also held together along most of their length by the strong but flexible interosseous membrane, which prevents the two bones moving lengthwise relative to each other. Let's look at the proximal ends of the radius and the ulna. We'll look at the ulna first. The main feature of the proximal end of the ulna is this large curved articular surface. The curve that it forms is called the trochlear notch. It articulates with the trochlea of the humerus. The very proximal end of the ulna is the olecranon. The triceps tendon is attached to it. This projection is the coronoid process. Distal to it, this rough area, the ulnar tuberosity, marks the insertion of the brachialis tendon. This small curved surface, the radial notch, is where the head of the radius articulates. This is the head of the radius. This is the neck. The end of the head articulates with the capitulum of the humerus. Its curved side articulates partly with the radial notch of the ulna and partly with the ligament that surrounds it, as we'll see. Just distal to the neck is the radial tuberosity, which is the insertion for the biceps tendon. Now let's look at this unique joint where two quite different things happen. the humerus articulates with the forearm bones to form the elbow joint, and the forearm bones articulate with each other to form the proximal